All right, everyone. It's been a long time since I've made any lesson videos, but here we are. This is going to be our first lesson of the school year. We're going to do a chapter 0. Chapter 0 is mostly going to cover some algebra review, things that you should have learned last year, and things that will come up very soon in chapter 1. So I chose specific things to put into this chapter 0, knowing that they would come up during chapter 1. Okay, so today for lesson 0.1, we're going to just do an overview, types of numbers, and mathematical operations. In all of the lessons slides that are posted on Google Classroom, there will always be a slide like this that has the lesson video link. Obviously, this slide doesn't have the link in it yet because I'm currently creating the video. This is stuff that I'll take care of in class to make sure you turn in any signed syllabi. Okay, remember it's your first assignment. You can start the year off with an A. Same thing with the Show Me What You Know survey. Okay, we did this in class already. It's posted in Google Classroom. Make sure you finish it if you've not. This is your first grade in the exit ticket section. Okay, make sure you start off the semester with that 100%. Okay, it's way better to start your semester off with a great grade than start off with a low grade and have to climb your way back out. Hey, in Google Classroom as well and in class, you will always be given a set of notes. This is our very first lesson. It's extremely important to take detailed notes. Your notes should be where you always return to when you're working on your homework or you're preparing for a test. Whenever you have a question, the answer most likely is going to be in your notes. Okay, so your notes are very important. For me personally, I hate writing. The way that I style my notes, I will never make you write a ton because I wouldn't ask you to do things that I wouldn't want to do myself. Okay, so the way that the notes will work, you will see it will be a fill in the blanks situation. Okay, math can be hard. I don't want you to have to memorize things, but I do want you to be able to utilize your notes and know where to find things. Hey, there are so many ways to, different ways to classify numbers. Okay, here's a list of numbers. There's a bunch of random numbers that we just put in there. Think of all of the different ways that you can classify these numbers. The same number can even be in multiple different categories. Okay, so I want you to pause this video. Think about what are some types of numbers in which you can put these into. Okay, if you pause, that's great. Some things that usually come up, we see whole numbers, positive numbers, we see fractions, we see decimals. There are some odd numbers, there's even numbers, there's prime numbers, okay, so on and so forth. Okay, so there's a bunch of different ways that we can classify these numbers. Can you think of any types of numbers that are missing from this random list of numbers? Go ahead, pause the video and think of what are some things that are missing. Okay, great. If you did pause and if you thought about it, some things that are missing, right? There are no negative numbers. There are no irrational numbers. Okay, things like that. Okay, so now we get into our notes section. As you can see, the way that I do my notes is based off of a fill in the blank. So anything that you see here that is underlined, right? Everything that is underlined correlates with a line that is on your notes. So whatever you see that's underlined on the board, or for example, or in this video, for instance, that is what you are going to write in the space that is on your paper. Okay, our first vocab word are real numbers. Those are all numbers along an infinite number line. This includes rational numbers and irrational numbers. Okay, we will only deal with real numbers in this class. As you go on, I think you learn in Algebra 2, there's a thing called imaginary numbers, but we don't need to worry about that in this class. Okay, so real numbers are basically any number that you can think of that is an imaginary, that's a real number. Okay, so along an infinite number line, it includes rational and irrational. That means it can be negative 27, it can be 2,491, it could be negative 1.111111112, and it can be basically any number that you can think of. The The natural number is also called the counting numbers. These are all positive numbers that do not have a decimal. And 0 is not a natural number. Let's think about it. If it's called the counting numbers, whenever you're counting something, you're counting your, I don't know, marbles in a bag, you never count 0, okay? So it's just all positive numbers that you would use to count. So that would be 1, 2, 3, 4, etc. Okay. Moving on, next vocab word are whole numbers. These are all of the natural numbers, but now we just include 0. Okay, a whole number is everything that we listed just up above, but now 0 is included. So again, now this is just 0, 1, 2, 3, 4, and so on. Okay, an integer. An integer is whole numbers and their opposites, which means now we are including negatives. Okay, so all of the whole numbers are also integers. Okay, and integers also include the negative numbers, right? You can think of an integer as anything that you would see on a number line. Okay, and if we look in the front of the class, we have a number line. So that would be -4, -3, -2, -1, 0, 1, 2, 3, ... and it's ... in both directions because it can get more negative and it can get more positive. Moving on are rational numbers. Rational numbers are all integers plus all fractions, terminating decimals, and repeating decimals. So again, right, think of this as like an umbrella. As you can see that a lot of these categories or a lot of these types of numbers are included in other types of numbers. For example, a rational number includes all integers. So everything that we talked about in integers is also underneath the umbrella of rational numbers. Rational numbers now also adds fractions, terminating decimals. Terminating just means that it stops, and repeating decimals. If it's repeating, so technically it goes on forever, but as long as it's the same thing over and over and over. So again, we'll leave the integers, -2, -1, 0, 1, 2. Now any fractions that you want, 3/4, 1/2, 22/7, whatever that you want. Any type of decimal that ends, 3.5, and any decimal that continues. Let's go with 4.12, and the 1, 2 is repeating. So that means technically it's 4.12121212, and technically it goes on forever, but it at least is the same number repeating. Irrational numbers are numbers that cannot be written as a fraction. That means the decimal continues forever, but at this time it is not repeating. The most famous example of an irrational number would be pi. We all know that that is 3.1415, blah, 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 blah. And that continues on forever. Another example of an irrational number would be the square root of 2. If you were to type into a calculator, what is the square root of 2? Let me do that here real quick on my calculator. Square root of 2, that is 1.414213, blah, 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 blah. It continues forever. Okay, so those are all of the types of numbers that we will need to worry and work with in this class. Okay, now going on to some examples, check which categories each number belongs to. All right, I want you to pause the video and see if you can check which one goes with which number, and then you can unpause it and go over it with the video. Okay, so 0, is 0 a real number? Does it exist? Yes, it does. Is it irrational? Does it have a decimal that continues forever? No, it does not. Is it rational? Yeah, if you need to, scroll back up. What's the rational? All integers plus all fractions. If we look at rational numbers, okay, we see that 0 is included in the rational number. So that means, yes, 0 is a rational number. A whole number is all, if you need to, just scroll back, check. What's the whole numbers? Natural numbers, and 0 is included. So again, 0, it's in there as well. That is a whole number. Is it an integer? Yes, it is. Is it a natural number? No. No, it is not a natural number. If you need to, scroll back up. The natural number is the counting numbers. And remember, we don't ever count with 0, so 0 is not a natural number. Negative 27, is it a real number? Yes, it is. Is it irrational? No, it is not, because it does not have a decimal that continues forever. Is it rational? Yes. If it's not irrational, that automatically means that it is rational. Okay, is it a whole number? If you need to, go back to whole numbers. Whole numbers is natural numbers and 0. So notice, negatives are not included in whole numbers, so it is not a whole number, but it is an integer because integer does include negatives. Natural number, again, counting number. Do we count with negative 27? No, we do not, so it's not a natural number either. Okay, square root of 3. It is a real number. It's not imaginary. It is real. Is it irrational? Well, remember, irrational means that the decimal continues on forever. If you need to, plug that into a calculator. The square root of 3, it's 1.732050808, blah, 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 which means it is irrational because it does continue forever. If it's irrational, that automatically means it's not rational. Is it a whole number? No, it has a decimal. Is it an integer? No, it has a decimal. Is it a natural number? No, we don't count with it. Okay, pi is a real number. It is irrational, which means it's not rational. And again, if it's irrational, it automatically is not going to be any of those others. Okay, 27 over 29, it is a real number. Is it irrational? No, it is not, because it is written as a fraction, which means that the decimal does not continue on forever, which means if it's not irrational, it is rational. Is it a whole number? No, it is a fraction. Is it an integer? No, it is a fraction. Is it a natural number? No, we do not count with it. Okay, in this example, we didn't have any good natural numbers, so let's go ahead and add down at the bottom. Let's put in 10. 10 is a real number. It is rational. It is a whole number, it is an integer, and it's a natural number. Okay? Next are mathematical operations. Does anybody know what a mathematical operation is? Okay, the definition, a mathematical operation refers to calculating a value using operands and a math operator. Okay, and sometimes definitions are not super helpful, like cool. What does that mean? What's an operand? What's a math operator? Basically, an operation is basically just doing math to a number to turn it into another number. Okay, so I want you to think, what are the most common mathematical operations? Go ahead and pause the video and think, what are the most common types of math that we do? If you unpaused, right, the 4 major most common mathematical operations are addition, subtraction, multiplication, and division. What are some other operations that are less common? Pause the video, think, unpause. Some things would be like exponents, right? Exponents is things like squared, cubed, to the 4th power. The opposite of exponents is roots, square root, cube root. We're going to learn later on in this school year trigonometry, which are different type of operations. There's things called logarithms. In calculus, you'll do things like derivatives, limits, etc. Okay, but for the most part in this class, we're just going to deal with the main 4, and then we're going to do a little bit of exponents and roots. Inverse. In math, inverse is the word that we use to mean the opposite. Okay, which means that each operation has an inverse, or we can think of it as an opposite. What are the inverse operations? The inverse operation of addition is subtraction. The inverse operation of multiplication is division. And the inverse operation of an exponent is a root, which means, and obviously the opposite, it can be flipped. The opposite or the inverse of subtraction is addition. And so